Hey there, everybody. Welcome back. We're in 15.4 for Calculus 3. We're looking at Green's theorem, and we already showed you what Green's theorem was. It's the closed loop on the curve C, the line integral for f dx plus g dy, where f and g are the components of the force or the vector field. That equals the double integral over the region captured by it, by the line integral, for dg dx minus df dy times dA, and this was the rotation matrix that we had. And it's related to the two-dimensional version of the curl. Let's prove that this is true. So it's got two parts, A and B. We could put this closed loop integral with each of them separately. I'm going to do that. We're going to look at A, and you'll see that B is identical to it. So for A, we want to do the closed loop for f dx. So we're gonna have a closed loop. It's going around here, and starting over here, it goes to B and it comes back around. Broke it up into two loops. The bottom half we're going to call g2 of x. The upper half we're going to call g1 of x. Now, normally when we're integrating, we don't go right to left like we do up here. So we're going to look at flipping that around. But first off, we're breaking up our closed loop into those two pieces that are not a closed loop. And then to work with C2 or C1, I'm going to flip it the other direction. I don't like the way it's looking. I'm going to flip it the other direction by making it negative C1 and changing the sign out front, as we saw we could do with line integrals. Okay, back in 15.2. And it's because we want to go from left to right, because we want to go A to B. So now let's look at our parameterizing our curves. Negative C1 and C2, we're going to set both equal to x equals t, and y is going to equal the g1 of x or g1 of t, and y equals g2 of x or g2 of t. And now we can use t is going from A to B on both of them because we switched the direction C1 was going. We're going to go along negative C1. So negative C1 is back that way. Okay. So let's plug in what we have. We've got negative A to B for f, and then dy, or I'm sorry, dx. We need to do dx in terms of dt. So it's going to be x prime t dt on both of them. X prime, but it's different for each curve. Well, normally it would be different for each curve. Dx dt, or dx on each of these is just one dt. So that's handy. So we'll change our function to looks like f's with t's in them. So we've got f of t, g prime of t, minus f of t, g2 of t, not g prime of t, g1 of t, and g2 t. Okay, that's where we're at right now. I'm going to write this in this format because this should look familiar. When we got something subtracted and there's a different component on each of them, this is just the output of integration, right? So if we integrated df dy, we would get f. And then going from y, the upper y to the lower y, we would get that. You can see working backwards, we'll get that by looking at our picture. But now we're going forwards. We're undoing that integration to work backwards. So rather than this turns into the integral of df dy from g2 to g1 and then dy. We've got dt here, but dt is the same thing as dx. So I can change my dt to a dx. And this now looks like negative a to b of g2 of x to g1 of x, and then df dy, dy dx. And this stuff is that's my region R. A to B for x and g2 of x to g1 of x for y, that's R. So my closed integral for f dx is the negative integral of df dy. Okay. That's where we're at. Okay. Just make sure you follow it. The C1 is right here. C2 is right there. I pulled a negative sign out front. This is hitting all of it. So negative, negative gets me back to positive. We are going backwards on integration. Normally we start here and work this direction. We integrate df dy, we get f. We evaluated our boundary limits, g1 of t, g2 of t, and we get that. Just make sure you follow that. We can do the same thing to find dg dx dA, or the closed loop around g dx, g dy. Yeah, I was just doing dx, right? Yeah, I was just doing dx. This should be dy. We do the same thing. We have a lower limit down here, C, and upper limit D here. The left one is H1 of Y. The right one is H2 of Y. We're going clockwise normally when we integrate upwards. So we're going to work along this as negative C1. And you'll see everything works out pretty much the same to get this component. I suggest you give it a try. And if you pause the video and took these notes, you can kind of mimic this setup and make sure you follow it. All right, that's it for this video. Next one, we're going to be doing examples with Green's theorem. Peace.